If you get into the resources section, you'll find a file called fpu_start. So you can go ahead and open that up now. I've already started off with a few blocks here. Now these blocks are the same blocks that we've built in a previous course called Design a CPU. So if you haven't completed the course Design a CPU, then the first 10 or so videos are free, so you can go in and you can have a look and see how these blocks are built if you're interested. Now if you've already done that course, then you'll recognise these blocks. So this is going to be the 1 bit of memory, the 8 bits of memory, an 8-bit enable, and the registers built up with the 8-bit of memory and the enable. So it means that the set goes high, we can bring information into the memory, and whenever enable goes high, we can take the information out of the memory onto the next location. So this allows us to control the flow of information round about our design. So we're going to use this in order to create a 32-bit register as opposed to an 8-bit. So let's go ahead and we'll just change this 8-bit register into a 32-bit register. So we want a 32-bit register, so let's take 4 of these 8-bit registers. Let's Control C and Control V to copy and paste. Now we're going to need the set and the enable, so we'll provide those with the tunnels. So we'll face that north, and we've already got that one there, and it's a tunnel and it's 1 bit, and we've called it set. And we'll put another one there and we'll call that ENA for enable. And we can copy these and put them into the respective pins. So this has got our sets and our enables. Now what we want to do is look at our input and our output. So the input and outputs are going to be 8 bits each, and we want to feed these out to a 32-bit bus. So we're going to use a splitter for this. So here's a splitter here, and what we'll do is we'll make the splitter, the bit width is going to be 32, but the fan out is going to be equal to 4. So that means that what's going to happen is you're going to get 32 bits coming in through one port here, and then the other 32 bits are going to come out of it 8 bits at a time. So we're going to connect this one here to here, so that's the first 8 bits, the second 8 bits, the third 8 bits, and then the fourth 8 bits. And then what we can do is we'll take the same splitter here and we'll place this at the output. So the output, remember to connect 0 and 7, we'll have to go to this one, and then the next lot will go here, and then here, and then down here. So now what we'll do is we'll stick in a couple of pins for the input and the output, and these are going to be 32-bit pins. So this is an input pin here, and it's got to be 32 bits, and we'll face it east, so it is facing east here now, and we'll face the actual label, we'll face this west, and we'll call this label here FP underscore input, and we'll do the same for the output, and we'll face the label east, and we'll call it FP underscore output, and it's going to be 32 bits. So that's us almost done. We're just going to put the pins for the set and the enable. So we'll copy the tunnels, face those east. Well, actually we'll face them west, and we'll put the set on top and enable will be on the bottom here. And we'll just connect a couple of pins to these. So these are going to be input pins, and I'll put that west, and we'll call that pin is going to be set. Copy this, and we'll call this pin ENA for enable. So that's us built up a 32-bit register, which we can use to control the information flow into our floating point multiplier. So let's go ahead and we'll create the hierarchy for this. So we can click on Project, Add Circuit, and we'll call it FPU underscore reg underscore 32. We'll go into main and we'll copy or cut, so Control X, and we'll put it into reg 32, so that will be Control V. And then we can get in, we can edit circuit appearance, and we'll just change the shape of it. So again, you can go in here and make it whatever shape you would like. So this is going to be the output here, and we're going to have the input pin. So that's going to be our input, put it in the middle, and we're going to have our set, and we're going to have our enable, and we'll grab our little section here and just place it up here. So we'll call the input I, the output O, and we'll have an S for set, E for enable, and we'll call it FPU reg 32, and just position these here, I for input, O for output, set, and enable, and we'll make these bold. So if we click on them and change it to 16 in bold. So that's FPU reg 32. So that's us now got our 32-bit register, and we can use this now to control the flow of information into our multiplier. Now what we want to be able to do is to split up the 32 bits into the sine, the exponent, and the mantissa. So we go back into main, and you can grab our new 32-bit register here. Now we're going to need one for the X, and we're going to need one for the Y. So the input here is going to be our 32-bit input. So we've got our input here, and we're going to have our 32 bits. And we'll call that FPU underscore input X. And we'll face this west. And we'll copy that, and we'll get another one for the Y, and we'll call that input Y. Now we're going to have the output as well, but we want the output to be split. So again, we're going to have to use a splitter. So if you get into the splitter here, and we'll face this left-handed. So so it's facing over here, and it's going to be a 32-bit here, so it's 32 bits, but the fan out is only going to be 3. So we're only wanting 1 for the sine and a set for the exponent and a set for the mantissa. So let's change these in order to allow us to get them into the right order. Now we want to keep the same format as we did with the theory. So what we want to do is, if you note the input here, the least significant bit is actually this bit here, and the most significant bit is this bit up here. So it actually runs from the least significant bit, and it runs along this way, and then it comes up to this one and runs along that way, then comes up to here and it runs along there, and it gets up to the final row and it runs along this way to get to the most significant bit. So that's least significant bit to the most significant bit. Now the way we have went through our process here is that we've decided that this bit here, which is in this case will be the most significant bit, is actually the sine bit. So we want the sine bit to be this one. It means that the next 9 bits which run along here to this point here is going to be the exponent, and then the remaining 23 bits are going to be the mantissa. So it runs exponent, it runs sine, exponent, mantissa. So what we want on this splitter here is the 32nd bit. Okay, that's the most significant bit, is going to be the sine, so there's going to be one of those, and then the next bit along is going to be the exponent. So the exponent, so there's going to be 8 exponents, so there's going to be, that's 1, 2, 3, 4, 5, 6, 7, 8, and then the next position, which is going to be the position 0, is going to be the mantissa. So the rest of these are going to be set at 0. So I'll just quickly flick through here and set them up, and I suggest that you just go ahead and work away along with me and just generate the same circuit. So it means that we've got 23 bits, so it's actually 0 to 22, which is 23 bits for the mantissa, and then we've got 8 bits for the exponent and 1 bit for the sine, and that's the bits that you can see here. So that's a handy way of splitting up the output, and we're going to do that for both the X and the Y. So let's put our pins and our tunnels in, and we'll finish this off. So we need our set, and we need our enable. So that's us finally got that built. So this here is going to take our X input and it'll split it into the sine, the exponent and the mantissa for X, and it'll take the Y input here and it'll split it into the Y, sine, exponent and mantissa, and it'll also control the flow of the information through the multiplier with the set and the enable. So let's go ahead and we'll create an instance for this now. So if you go up to project, add circuit, and we'll call this circuit FPU underscore 32 underscore say X underscore Y. So again, to the main menu, we'll control X, we'll take it out and we'll put it into our new instance here, and then we'll go ahead and we'll project edit circuit appearance, and this is the appearance of the circuit here. So we're going to have to just adjust this and we'll make it a bit neater. So we're going to have the output here. You can see the output. Again, whenever you're doing this, whenever you click on it, you'll see it down in the bottom left hand corner, the right hand corner, and it shows you the actual pin here. So we've got to score a map, make sure that you match up the pins correctly. So this one here is going to be the X input. That's the X input, and we're going to have the look for the Y input. So let's see, that's the Y input there. That's X input, the Y input, and then we're looking for our set and our enable. So let me go ahead and I'll build this, and you can do the headset the same as well. Just go ahead and build this instance. So that's me going ahead and finish this. We've got the X input, Y input, we've got our set, we've got our enable, and on the output we're going to have the X values for the sine, the exponent and mantissa, and the Y values for the sine, the exponent and the mantissa. So let's go ahead and we'll test this out. So head up into main, and you can grab that instance there that we've just created. Now we're going to stick a couple of inputs in. So there'll be an FPU X, so there's an input, got to be 32 bits, and we'll call it FPU X. Okay, and we'll just place this again, we'll place it west, and we're going to have an FPU Y. FPU Y. And our outputs here are going to be our XA, S, XE and XM. So it's just going to split this up into our three components. And we'll also have our set and an enable just to control everything. So we'll just pop a couple of pins. So here's a pin here, and we'll make it single bit 1 facing north. Pop it on, and we'll call this set. So that's going to be S for set, and this is going to be south. Okay, Control C, Control V, paste this in. This one here is going to be E for enable, and we can put our output pins here. So our output pins are going to be the single ones for our, well, let me just go ahead and I'll put these in, and you can go ahead and put them in as well. So that's me finished building this up. We've got our set and enable pins here. We've got a couple of pins in, the X and the Y, and we have our X values here, one for our sine, which is a single bit, 1 bit for our exponent, which is the 8-bit, and the other one for the mantissa, which is 23 bits, and the same goes for these three here, which are our Y values. So let's go ahead and we'll try this out just now. So nothing's going to happen here until our set and enable have gone high. So I could change these values here. Of course, nothing's going to change in the output. Now I can read these values into this register. So when I press set, the values are read into the register. So we can come into the register here, and all of these values are read into these registers here, and you'll see that they're all sitting in the memory locations. But those values won't pass out to the output until the enable has gone high. So if we come back here again to the start, then these values here will get passed out whenever the enable goes high. When the enable goes high, the values are now passed out, and you see that they're split. There's the 0 bit here, so this bit here does the sign for the X and the sign for Y, and these bits here, the next 8 bits, do the exponent for the X, and this what these 8 here do the exponent for the Y. And of course we have the remaining 23 bits, which are the mantissa values for the X and the mantissa values for the Y. So that's everything all split up, ready for us to go ahead. In the next video we'll start looking at the sign, we'll do the sign bit, and we'll also make a start on adding the exponents together. Thank you for listening. Get you in the next video. Goodbye.